Okay, to go through the problem on the notes, we have our 5 equations that are given, and we kind of have to read the question and pick which equation works best for that given problem. The acceleration in each equation is the same variable. It's representing the same quantity. Same thing with displacement or velocity. But some of these equations, if we notice this one is missing displacement, if we have a problem that's asking for displacement, we couldn't use it. So things like that. The problem reads, a police officer is sitting on the side of 294 using his radar gun to try and catch speeders. After a red Corvette whizzes by too fast, traveling south on 294, the officer has to accelerate from rest to a speed of 38 meters per second to catch the troublemaker 700 meters ahead of where he started. So if we don't know instinctively which equation to use, the best way to start is by writing out the known information. And so in our problem, we're given that the officer has to accelerate from rest. That's a giveaway that our initial velocity is 0 to a speed of 38 meters per second. That would imply that his final velocity will be 38. And it's catching the troublemaker that's 700 meters ahead. 700 meters implying that that is a displacement. If I were to write those out, VI equals 0 meters per second. VF is equal to 38 meters per second. Displacement is equal to 700 meters. And we are looking for the time. So this question specifically asks, what amount of time did it take him to catch the speeder? We have to pick an equation that matches these variables that were given and the one we're looking for. So in the first equation, we see final velocity, which we have. We see acceleration, which we don't have. We're not looking for it quite yet. That's in part B, but we don't have that. So this equation, we are not going to be able to use. We have 2 things we don't know, acceleration and time. We can kind of go down the line and figure out which one we can use. So we have displacement, yes. We are looking for time. We have initial and final velocity. So right off the bat, this one will work. Notice all the other 3 have acceleration in the equation. So we are going to pick this one, as I expect to write out your equation that you're choosing. And then we're going to plug in or substitute in those variables, or the quantities for those variables. So 700 meters equals 1/2 times time times our initial velocity plus our final velocity. And after that, you can solve for t. So 700, you add these 2 together. You don't have to show this work if you don't want to. 1/2 times time, this goes to 38 meters per second. 700 is equal to 1/2 times 38 is 19 meters per second times time. And then divide both sides by 19. And you get a value of time equals 36.8 seconds. Now, you might be kind of realizing that this says he's traveling south on 294. That would realistically make our final velocity negative and our displacement negative, which really does not affect our answer, as we would still get a positive 36.8 seconds. On the next part for problem B, what is the police officer's acceleration? You now can use this time if you would like to, but I tend to shy away from using an answer I found in case this answer was wrong. It would cause me to get B wrong, and we have enough information to solve just for the acceleration. So I kind of look at my information. Initial velocity is still 0. Final velocity is 38. Our displacement was 700. And we're looking for acceleration now. You can throw in your negatives if you'd like to imply that they are moving south. For this, I notice that I have VF, VI, displacement, and acceleration. The equation that I have to use for that, to find our acceleration, this one has time, so we aren't going to use that. This one has time, we aren't going to use that. This one has time, we aren't going to use that. So this one right around here, VF squared equals 2a delta x plus VI squared, is one we could use. So write that out. Plug in our variables. So for VF, so we have negative 38 meters per second squared is equal to 2 times a, which is what we're solving for, negative 700 meters plus an initial velocity of 0 meters per second squared. Once you simplify this, that does kind of go to 1,444 meters squared over second squared is equal to 2a times negative 700 meters. That reduces to 0. And divide both sides by 2, divide both sides by negative 700, and you have an acceleration of negative 1.03 meters per second squared. For the motion map, this is just to kind of show what we're looking for. It should match our values. We're going to draw a qualitative one, not to be able to show 36.8 seconds. But traveling south starts at 0. Acceleration is also negative. So therefore we have our police officer that is able to speed up over time. And that one will be off the page. This method is just really a problem-solving method for solving any math problem that you are not using your graphs for. Coincidentally for B, you could have also used VF is equal to AT plus VI. And if you plugged in the time from the problem you solved for before, you can solve it again and you would get exactly the same acceleration. So it is up to you what equation. You could have also used, if you wanted to use the time, you could have also used delta x is equal to VI times t plus 1/2 AT squared. Both of those also were options to use for this problem. Good luck!